Alright, this is chapter 7, problem 4. It's the one where there's a beam and you had two forces, F1. All the forces are 200 newtons, and F1 is here, F2 is there. F1 is 1 meter away, F2 is 1.5 meters away. So what I do is I don't use the cosine, theta, and all these equations. What I did is I come over here and I figure out the components. So this is the first one. This is F1. So what I did is I just take cosine 40 blah 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 is F1y over 200 newtons, and I get F1 in the y direction, which you can see it's this it's the piece down here. And remember, if there's a torque on a system, the torque is created by a perpendicular force. So this F1 and the x, this thing here has nothing to do with torque. The only one that has anything to do with it are in the y direction. Let's go back over here. If you go over here, you'll see that I do the same thing and I figure out F2 in the y, and that's 100 newtons. So I know F1 in the y is 187 and F2 in the y is 100 newtons. So it asks us to figure out the torque on the system by these two things. So what I do is I sum up the two torques. Both these torques rotate this in a clockwise direction, so they both are working together. They're not working against each other. So when I sum up the torques, torque is force times radius arm length. So I have F1 in the y times R1 plus F2 in the y times R2. That's not R squared, that's supposed to be R2. So when I sum the torques, I take the force, multiply it by the radius arm length, and I get 337 Newton meters. It's a negative because it's clockwise. Next step for B. For B, we're down here. Redrew the picture. They want to know how to make this system work. So what this is like a sign, and it has two things hanging from it, and this is the cable holding it up. And they want to know what this radius length needs to be so that this can be 200 newtons, because that's probably all the cable can withstand. So what we do is we sum all the torques. And when you sum all the torques, they have to equal 0, because this thing can't be moving, and they have to equal each other. So when I sum all the torques, I get F1 in the y times R1 plus F2 in the y times R2 plus F3 times R3. And if you look, F3 is just this force. It's the whole thing is in the y direction because it goes straight up and down. So back over here, and it has to equal 0. So I just plug stuff in, just like I did up top. I did the negative 187 because it's rotating this, it's going down. The 100 plus 100 right here, and that's times 1.5, and I get, this is supposed to be a negative also. So I add all this stuff up and I get negative 337, which is what we figured out before, plus 200 times R3. And what I do is I just figure out what R3 needs to be so that this thing equals 0. So I have to multiply 200 times a value so that it's equal to 337, so that these two things cancel out. And that value is 1.69 meters. If I put 1.69 meters in here, I get negative 337 equals 337. That equals 0. So the radius, the distance from the wall to this force, has to be 1.69 meters.